Going up and down in an elevator is a classic physics question. So here you are, you're looking rather stick-like, but you're happy. You're in the elevator, the cable's up here. The cable is not attached to you, remember? What moves you is the floor. So you get on the elevator. When you get on the elevator is at rest. And when the elevator is at rest, your weight, let's say that you have a mass of 65 kilograms, and so your weight, no, sorry, 60 kilograms, that's the number I think I used. Yes, 60 kilograms. So your weight is going to be 588 newtons. When you get on the elevator, it's at rest. The normal force, which is the force of the floor up on your feet, is equal to your weight, 588 newtons. Then you press the up, you want to get up to the 16th floor, and so the elevator starts to accelerate with 2 meters per second squared. Well, your weight doesn't change, but what happens is that the net force is no longer zero. That's because the normal force, the force of the floor on your feet, has increased above 588 newtons. If you've ever been on an elevator or something that bumps you up, you can feel that. It's as if you feel pressed down against the floor, like, whoa. To calculate that, the value of the normal force, given that acceleration, net force equals mass times acceleration, which your mass is 60. 60 times 2 equals 120 newtons. That's not the normal force. That's the difference between the normal force and the weight. And since it's upwards, the normal force is 120 newtons greater than your weight. So the net force, remember that Newton's second law is not the definition of net force, it's just that net force causes a mass to accelerate. Thank you, Isaac Newton. In this case, the net force is the difference between these two forces, normal force minus weight. So 120 equals the normal force minus a weight of 588. You solve for the normal force by adding 588 to the other side, and that comes out to be 708 newtons. I do want to add that this is an elevator going up and speeding up. It's also an elevator going down and slowing down. The other time you feel pressed down against the floor is when an elevator is coming down and comes to a rapid stop. If it's going up and speeding up, you feel pressed down against the floor. I mean, take it to the extreme where it goes really, really fast. You get squished against the floor as it accelerates upwards. The other time that happens is when it's going down and stops abruptly. They both feel the same because you have a positive acceleration. The normal force is greater than weight when an elevator is going up and speeding up, and going down and slowing down. The opposite of this is when an elevator is traveling with a negative acceleration. Well, when does that happen? It happens when you're going up and slowing down, or when you're going down and speeding up. So you are approaching the 16th floor, and it's slowing down to a stop on the way up. That's negative acceleration. So net force is negative 120 newtons. Again, you're going up and slowing down. What is the net force? It's the difference between normal force and weight. So negative 120. By the way, I forgot, this would shorten, right? The normal force isn't pointed down. The floor is still supporting your feet. It's just less than your weight. It's less than your weight by 120 newtons. The normal force is less than your weight, but it's still pointed up by 120 newtons. And the normal force would come out to be 468 newtons. Again, the 2 times that happens is when you're going up and slowing down, you get to the 16th floor and you realize, whoops, I forgot something, and you have to go back down. So you press the lobby button, and it accelerates downwards, speeding up at negative 2 meters per second squared downwards. That would be the same value. So going up and slowing down, going down and speeding up, this would be the same.